Let's look at how I calculated for this path length. So we've got 8 bodies, and so we'll have 7 divisions between there. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So what's going to be the count, the number of bodies minus 1. And so I went into my parameters and I created a parameter named count, and then I give it the number of bodies, and that's the unitless number. So you have to make sure you set it as a unitless number. Then I created a variable called spacing with the desired spacing, and then the path length is going to be count minus 1 times the spacing, and that tells us then that path length that we need is 588. Okay, so we need to remember that number 588. Actually, we don't need to remember it because Fusion will keep track of it, but I'll say okay to that. And then if I look at the first sketch, so I offset this for the path to give the desired distance away from this line. And then I put in 2 points in here, and I put in the spacing. So this point is mirrored on the other side of this one. For the spacing, we don't really need these 2 points, but I just put them in for illustrative purposes. And then I dimensioned the length of this line, and then I need the length of this curve. And so I'll go to the inspection tab and I'll click on that curve, and it gives me the length of that curve out to 8 decimal places. Now we could also calculate the length of that curve, but we'd have to put in the formula, and for me it was just easier just to, if I click here, I can copy that to the clipboard. So I'll click on that value to copy it to the clipboard, and then I need this distance from here to here so that the length of that path going around here will equal to that 588. So I know that path length, and then I need to subtract 2 times the length of the curve, this one and this one. And again, I didn't have to remember that number. I could just paste it because I put it on the clipboard. Okay, so 2 times the length of the curve minus D9, that is the length of this line from here to here, divided by 2. That gives me the length of this line and the length of this line over here to equal that total of 588 for the curve length. All right, for the path length. All right, then I'll accept that and finish my sketch. And I then did my second sketch on the origin plane. I prefer, whenever possible, to use the origin planes to do my sketches rather than on a body, because the origin planes they can't be erased, they can't be deleted. And so that's the most robust way of doing it. And then when I did the extrusion, I did an offset um, to the object. So if I did to this object out here to this point, that's where I wanted it, and then the distance of 1 for the thickness of the panel. And then did the pattern. So let's look at the pattern. So I'll edit that pattern. Um, Notice this number rounded off will be 588. And actually, and this is with it set to extents. So the total length of the pattern, count the number of instances. And let's look at this from the top view then. If you drag, so our start point is over here, okay, at 0% of the path. And if I drag this arrow, so initially it would started over here someplace. If I drag it, let's zoom in here. When I get to the end of the path length, you'll see a snap black. See that black point snap at the base of the arrowhead? Okay, so that gives me the length of that path, the 588. Um, and that's what we calculated it was. And then if I change this, instead of doing extents, if I do spacing, and I can put in, it already calculated the spacing, or I can put in the variable names for spacing, and then that's the other way that we could do it. But the point is we have to calculate that path length, and it's best if we start either at zero, the beginning percentage, or at 100% of the path.